Please welcome our Energy Department Technology Leadership Panel. Dr. Ilan Gur, Director M37, Lawrence Berkeley National Laboratory. Dr. Mark Johnson, Director, Advanced Manufacturing Office, Office of Energy Efficiency and Renewable Energy, U.S. Department of Energy. And Mr. Minh Lee, Director, Solar Energy Technology Office, Office of Energy Efficiency and Renewable Energy, U.S. Department of Energy. And please welcome our moderator, Mr. Jared Anderson, Managing Editor, Breaking Energy.
Dr. Berkeley. Hi, good afternoon, everyone. Thank you so much. Thank you to the Council and Department of Energy. And I think Secretary Moniz's talk this morning was a perfect setup for this panel, the leadership panel. And we have some intelligent and fabulous directors here. I am not a director, but I'll be directing the discussion. And I think the growth that we've seen on the supply side with regard to energy is nothing short of astonishing. But Secretary Moniz, put it well when he was also talking about the demand side and some of the things that we're seeing, and that really fits into manufacturing and how the role of energy is playing into that. And so, it's interesting, and I would be interested to talk to the gentleman today about some of the technologies that they're investing in and how those are playing a role in advancing manufacturing here in the U.S. So I think solar is an excellent example of that, and I think Minh has some very interesting examples of how advancing technology in solar is also playing a role in manufacturing.
Yes, definitely. What's really exciting for many of our renewable energy technologies that we cover at the Department of Energy in the Energy Efficiency and Renewable Energy Office is that the technologies that the federal government has invested in over the past 20, 30 years, a lot of them are actually on the precipice of growing at a very dramatic rate. You see that in technologies like wind and solar, and very dramatic increases. For example, at the end of 2008, we had about 1.2 gigawatts of solar deployed across America. By the end of this year, we might have close to 20 gigawatts. So a very dramatic increase in just the last several years. That's because the cost of solar, the cost of wind, cost of a lot of other technologies are getting to the point where it's economically viable, and it's certainly economically viable in a number of places. But the story, connecting the dots between deployment and manufacturing, which is certainly a lot of the things that we care about in terms of reducing our greenhouse gas emissions, it takes a whole village. When you connect the dots, it goes all the way back, and you can trace it all the way back to research and development. In fact, at the Energy Department, over the past 35 years, we funded well over 57% of the world records, the world record efficiencies. This is the laboratory technologies, that sometimes takes a decade to get into the marketplace. But over this long and consistent time span, our nation has some of the best national laboratories, research universities, and innovators. And they've broken new world records. They've pushed the envelope in terms of technology. So it all starts with innovation at our laboratories. It starts with innovation at our universities. And that innovation that we seed eventually makes it into the marketplace. And the question and challenge for all of us here on these chairs is to think about how to accelerate that innovation into the marketplace.
Fascinating. And as part of that innovation ecosystem, it's important to work with the private sector. And how do we find processes, and how do we really leverage the best of on the government side, and also working with the private sector. I think we saw an excellent example during lunch of how some of the government labs can do that, and Mark gave a very impassioned introduction to the 3D printed car, and that's a great example. But I'm sure you have some other examples of how working with the private sector is advancing manufacturing here in the US.
That's great. And Minh pointed out how we're at a precipice for a number of technologies that are relevant to energy, where we're reaching sort of cost parity with how things are done today. And often one of the challenges you face when you wind up running up against that is really how do you manufacture things so that you've not only got a superior energy efficiency out of something or a superior performance out of a new technology where we've done that invention, but all the other inventions, the secondary inventions you need to really drive the cost down, make it manufacturable, develop this cycle of continuous improvement so you're not locking down to one technology that as soon as you've done that, everyone else is trying to pass you at that point. But you're really having this continuous cycle of innovation. What we're finding is there's great inventors across the country right now that we can key into in small businesses, large businesses, in our university system, in our national labs, and really figuring out how do we work with them in a different way. And what we find the key to that is the magic is when you bring a bunch of researchers and you put them in the room with a bunch of people that do manufacturing or a bunch of product people, and then kind of get out of their way, right? It's empower them, hold them accountable for something, and then watch the magic happen out of it. We had a great example of this. We also, as well as the platform technology on additive manufacturing, another area we do this is at Ames Laboratory and a couple of other national labs where we have our Critical Materials Institute. And this is really trying to address problems around manufacturing related to rare earth materials. And this is a really important competitiveness issue. How do we wind up making sure that as we're manufacturing, we're not dependent on some materials? So how do we develop alternatives and substitutes and really a pathway forward that's manufacturable? Well, in the first year of standing that institute up, one of the key moments that happened was we had a group of researchers that they went and spent a couple days with a manufacturer that was interested in fluorescence, fluorescent materials that are used for lighting. And what was interesting is the scientists came in and they had like 30 different possible things that you could do to address that were new inventions. And the manufacturing people went through and said, nope, oh, this won't work at all. And then, hey, we'd never thought of that before. And when you get those, hey, we'd never thought of that before moments, then they wind up saying, well, we're constrained because of these other things in manufacturing, but we have an opportunity to drive the technology in this way. And then that brings people back to the laboratories and they say, oh, how do we solve it in this new direction? And you wind up developing these new directions of innovation. That's really, really exciting to see. I think a broad theme, people have talked about this today, is the whole role of information technology in manufacturing, whether it's controlling your processes, whether it's controlling your products, whether it's controlling your factories, whether it's integrating your factories into the energy infrastructure. These are all massively data-intense problems. So uniquely, the Department of Energy can wind up working with manufacturers and bring those technologies in there, so developing that as a platform technology.
Interesting. And I know that Mark and Ilan have experience at ARPA-E, and ARPA-E talks a lot about taking shots on goal, and they look at a lot of different technologies, and there's certainly no shortage of new and exciting technologies and ideas, but sometimes there can be challenges scaling them up and getting them to the manufacturing stage, and I think Ilan has some insight into that, and maybe you could talk a little bit about that.
Yeah, well, I mean, I think one of the themes in Min's and Mark's comments, the linkage between manufacturing and innovation, early innovation, is inextricable. We saw that at ARPA-E, funding many ideas and realizing that really the ideas don't have merit unless you have the techno-economics, unless you have the partners, unless you have a manufacturing model in mind that can get these things out into the world competitively. I saw that link from a different point of view, having in 2006 worked with a few just phenomenal scientists from Berkeley and one of the nation's top venture capital firms to start a company in the lithium battery space. And most folks here are probably familiar with the story, but most of the underlying technology for lithium-ion batteries was developed in our labs here in the U.S. Electrodes at University of Texas, electrolytes at Berkeley, et cetera. But ultimately, the manufacturing base took hold in Asia and in Japan. And so when we started this company in 2006, there were a few things we realized. One was to figure out whether our idea was going to be manufacturable or how we could manufacture it was a challenge because we couldn't find the people who could give us that expertise. They were all in Japan. And so that's kind of one of the limiting factors there. And so from a workforce standpoint, et cetera, I think the link is here. The other side of the coin is if we want to be able to, once you have an established base of manufacturing in another part of the world, how do you get it back? And running the business model for our venture, we said, well, it's going to be hard to imagine manufacturing the same technology that's already being manufactured there here. There are only a few ways, in my experience, that we've seen manufacture shifts. Some of them don't really have to do with technology. So, found a lot of natural gas in the US, that's going to obviously have a big shift in how we manufacture. I know Mark is thinking very seriously about that. There's policy, and so lithium battery manufacturing went from Japan to China, had a lot to do with policy. But then you have stories around innovation, right? Companies like Tesla Motors, that because they're a US company, they can actually build a story around manufacturing competitively in the US. Or companies that are saying, well, and ultimately this is where we started thinking about it in our company, well, if we don't manufacture the same thing, if we have a new technology with a different supply chain or a different process, we could bring that back. And so the link is inextricable. One of the things that I care deeply about and that I'm now working on post-RPE is the realization that you need a healthy innovation ecosystem. And you heard Assistant Secretary Danielson this morning saying, one of the things we've learned over the last 5 to 10 years, he didn't use these words, but is that one of our main innovation engines in this country to move ideas out into manufacturing technologies, namely the traditional venture capital model, doesn't seem to be working well in this space. And what that's leaving is sort of creating a market failure with a lot of stranded assets, a lot of wonderful ideas, a lot of entrepreneurial researchers, one of our strengths in the US, that aren't going to start those companies and aren't channeling their energy into how do we take science and move it forward. And so M37 is an initiative that we're running out of Berkeley Lab based on the hypothesis that one of the reasons venture capital didn't work was these are very hard technologies, capital intensive, you need equipment, you need interdisciplinary expertise. Turns out in our national research assets, the national labs, we have those things. We have equipment, we have expertise. And so the hypothesis for us is maybe that can be a place where we, it's not an academic exercise that you want to do, it's not a corporate exercise. And it turns out the national labs are neither academic nor corporate. Maybe this is a place where we could do this sort of work.
Sort of a hybrid model that, and that's one experiment, and then hopefully there can be other experiments as well.
Absolutely. You use the sort of shots on goal analogy, which is we take a lot of technology shots on goal. We need more shots on goals in terms of how we develop technology. And if the venture capital community isn't going to be engaged in this space, that doesn't mean that there aren't serious strategic interests here between corporates who need an innovation pipeline, between the government who wants to see these changes happen.
Right.
I think following up on that, I think one of the really interesting trends that's happening right now in manufacturing, especially advanced technology manufacturing, is how much a number of other states in the United States are reaching out to places like Silicon Valley and the Boston area and some of these technology development hubs that haven't necessarily been technology manufacturing hubs. But if they can wind up saying, instead of taking that technology that's coming out of Palo Alto and manufacturing it in China or in Malaysia, why not manufacture it in upstate New York or in Arizona or in Mississippi? And they're really getting very aggressive at this to saying, how do we wind up connecting that early stage pilot plants and really, catalyzing this insourcing movement at the state and regional level. That's really exciting to wind up seeing. The other thing that is really important on this is economic study after economic study is showing that the platform learning you have out of first manufacturing is a key in informing what the research challenges you have are. So under these sort of public-private partnerships we have, our goal is as you have these trends where now you've got first manufacturing on some new technologies going in the United States, how do you wind up using that to refresh and renew the researchers so that they're continually developing things that are relevant? It's not just inventing something because they think it might be important. They've got a potential manufacturer out there that said, hey, if you do these things, it's really going to matter to us. We can't do that ourselves. We need science and we need technology to have insight into that. but we are more than willing to be a partner in this and pull that back in. And I think when we have that ecosystem that's both in a given place and then connectivity across the country between those places, then we wind up really having this virtuous feedback loop on these partnerships.
If I can also connect the dots there, many of you might have heard a story just in the last month. A solar company down in Georgia, Suniva, just announced that they're going to expand manufacturing in the United States. And so that's certainly very exciting. But what Mark and Ilan said earlier is about that ecosystem, connecting the various aspects. By the way, Suniva used to also have manufacturing overseas, and they're bringing it back here in the United States because it makes sense for them to do that. And in fact, Mark's office he renamed his office is now renamed to the Advanced Manufacturing Office, and I created a new program inside my office called Innovations in Manufacturing: How to Help Companies Take Technology to the Marketplace. That shows you our commitment and our focus on helping take technologies not just from the earliest stages of innovations, but also all the way down to the later stage where it really matters and where it can grow the community. That technology that Suniva is taking into the marketplace by building new factories in the United States was really rooted in with Department of Energy funding. Some of the early ideas, and it's a really interesting story because it's not just one company that made it happen. It was research at Georgia Tech that we funded a decade ago, connecting with a very large manufacturing equipment company, someone who makes equipment to manufacture, Applied Materials, developing ion implant technology that was borrowed over from the semiconductor industry to apply it to the solar industry, and then Suniva, a solar company, taking that technology and able to out-innovate, manufacturing in other countries. It really takes a village, that connecting a lot of these different technologies and a lot of different parts of the supply chain in order to innovate in this country and to make it a product that you can make here in America. It's no longer about low-cost capital. Okay, you can overcome low-cost capital when you have a machine that can crank through thousands and thousands of products per hour. Okay.
Wow, and sticking with solar for a moment, talk about competitive, even like cost competitiveness with other fuel sources, and the cost of solar coming down dramatically. It's nothing short of astonishing. We were talking about this a little bit before the session. But what are some of the challenges to reducing the costs of solar and increasing the efficiency of let's say, PV panels?
Oh, certainly there are plenty of challenges that we have our best innovators working on, not just at the university, like I said, but at businesses. Challenges in terms of capital equipment, lowering the cost of capital equipment, lowering the labor content, trying to understand, what does it make sense for the United States to actually manufacture, okay? It's okay to not have to do everything. We don't need to manufacture everything, but can we understand where in the value chain, where is the greatest value for U.S. to manufacture? Like Ilan said, there's a lot of great things going on in America right now, like natural gas, our relatively low costs for energy, and the fact that our labor is actually very skilled. That actually tips the balance, if you will, away from offshoring. And so we actually have a whole team at the Department of Energy and our national labs that analyzes whole sectors of industries to understand, what are the critical levers that we can play, that we can pull on in terms of our investments to help move the needle so that it tips the scale between a decision that a company makes for manufacturing overseas versus domestically.
Wow. And so kind of getting back to some of the things that we were talking about at lunch and some of these new technologies and the role of energy and then the role of lower cost energy here in the U.S. and how are some of these technologies benefiting the U.S. public? I guess the car could be one example, but I imagine there are others.
What I look at on this is saying, okay, what are the assets we have that are competitive advantages? The ultimate renewable competitive advantage we have in the U.S. is innovation. We're the most innovative, scientifically advanced country in the world, bar none. As far as invention, we have been and always will do that. We go back to our roots on that every time. We run into some economic challenge and we say, let's just innovate our way forward. It's not trying to be the best economy of 2007. We're saying, how do we be the best economy of 2016, 2017, right? How do we invent our way forward on it? And you look at some of the challenges we've had as a result of that winds up affecting the public. You say, if we can wind up actually making cars that are cheaper, faster, better, and made in the U.S., you have multiple bottom lines on that. First of all, our end-use customers, that's a pretty cool car, or whatever you're going to make. If we're making cars, why can't we make wind turbines that way? Why can't we make, someone came up to me at lunch, why aren't we making jetpacks that way? So, the products we have will be better products. There's a benefit there. But just as important, what winds up happening is as we use less energy, we become more competitive. That always drives economic growth. And at the bottom line, you heard that Jason Miller this morning saying, economic growth, economic growth, economic growth. I heard a statistic recently, if we wound up increasing growth by just 1%, and we always go back to our high school algebra on this with compounded growth, by 1% over like a 25-year time horizon, we don't have any problem with budget deficits. We don't have any problems with Social Security. We don't have any of those things just by driving growth. And what drives growth? Innovation, technology. So we need to make sure we've actually got a responsibility to pushing these things out, to making sure that's driving our economic growth.
All right.
Can I leverage that off in a second and tell you a story about, and many of you might have heard about the announcement last week, Apple Computer announcing their new iWatch and iPhone 6. Well, there's actually a solar part of that story, and it's a really interesting story because the surface of that watch is made with sapphire. And so you ask, what does the Energy Department have anything to do with, sapphire and iPhones, iWatches, whatever? Well, it turns out that sapphire, which is on that phone, that watch surface, because it's really scratch resistant, was made in partnership, a $600 million partnership between Apple Computer and GT Advanced Technology to build a factory, and they have a factory down in Arizona to do that. Well, it turns out that GT Advanced Technology used to be called GT Solar. Okay, and GT Solar, back in the early 2000s, late 90s, had a number of awards from the Department of Energy and the Solar Office to develop advanced crystallization technology to make polysilicon wafers for the solar industry. They were enormously successful in that enterprise, okay? Grew that business to, I believe, over $1 billion. And they decided, hey, we did really well here. What else can we do with this technology? So they diversified. They diversified into other segments of the industry. They said, well, I'm going to make sapphire now. I have expertise in crystallizing semiconductors. I'm going to make sapphire. And lo and behold, 5-10 years later, they have a partnership with Apple Computer to do that. There's also other solar technologies in terms of peeling off layers of sapphire that's embedded in those watches. So it's really exciting to see. Because after all, the silicon that's used in the solar industry used to be the leftover silicon that was used to make computer chips. Think about how much we depend on computer chips every day. The polysilicon was leftover. Today, 90 to 95% of the polysilicon made worldwide goes into solar panels, not computer chips. It's reversed its way around, okay? And so the point of that story there is to say that innovation spreads. If you don't make stuff in this country, you're going to lose out on tomorrow's innovation sectors. Who would have thought that the solar sector would have grown out of the semiconductor industry? And who would have thought that the Apple iWatch would have grown out of the solar industry?
That cross-pollination really is fascinating and exciting. And I wonder what the chairman of the Bank of America was talking about what's going to be the next shale gas. And he was suggesting maybe energy efficiency. And he was talking about $8.8 trillion, a market of $8.8 trillion of good return projects that he envisions or that the bank envisions. So what technologies do you get excited about? And what do you see as maybe one of the next?
So, I think I said earlier, information technology is just broadly coming into manufacturing right now in new ways. And this is opening up things like new middleware capabilities. So if you think about what we have as national labs that we can wind up bringing to the table, it's things like high-performance computing. We've got two assets there. We've got the high-performance computers, and we have a bunch of PhDs that know how to program them. Our goal here is how do we get those out there so manufacturers can use them and wind up at the same time developing middleware so we can eliminate the need for the PhDs to be sitting beside you so then the manufacturers can just use it directly. So it's this continual evolution. By the way, when you talk to the PhDs that are doing that, they're not afraid of that because they know they can just reinvent the next thing that they're working on as well. So, this goes back to actually the history of the Department of Energy. This morning, Chairman Holliday was talking about who in this room could have possibly predicted, or who in this room did predict the shale gas revolution. Well, actually, it's this room that did. That technology was developed in the 1970s and 1980s in the Department of Energy, specifically to develop the expansion of shale gas. It was the coal bed methane projects, the horizontal drilling. They set up partnerships with the private sector. Mitchell Energy wound up taking that, opened up the Barnett Shale. It was an intentionality. It was a public-private partnership. It was spurred directly by DOE's ongoing technology investments. And so, we can do this over and over, and we keep coming back to doing this, and we will continue to do this.
Wow, that's great. That's exciting.
And, Mark mentioned the PhDs. I think earlier you said our greatest strength is sort of our innovation ability.
Yeah.
I would say the greatest strength is in the people who drive that, and the mentality that they have and they bring to these projects. I mean, we saw, John Rogers today give that speech next to the car, and that's what got everyone really fired up. One of the things we've seen as we've been working on M37 is a lot of folks who've been in this space for a while, I sort of described, and Assistant Secretary Danielson described, that the venture capital sort of funding is walking away. Folks who've been in this space for ages, many of you in the room have said to me, well, they shouldn't have been here in the first place, right? We could have told you that wasn't the right model. And so it's probably good that wasn't a model that was working. But I think what people miss is the fact that energy entrepreneurship was so exciting, right? What did that do? It brought some of the brightest, most innovative entrepreneurial minds to think about our problems, right? We went from, when I was at Berkeley as a grad student, there was no energy club, there was no classes on entrepreneurship and energy, et cetera. Now you've got those things spreading like wildfire. And I think the challenge for this group is to say, okay, now we've got all the talent, right? Our greatest asset, how do we harness it? Because I'll tell you, my experience at RPE toward the end of my assignment there was going around the country. I started finding those folks who were very gung-ho about this space saying, well, my friends are all telling me that, the venture capitalists aren't funding anymore. Maybe I should go do a startup in another area. And I think if we lose that asset, it'll be a tremendous loss. And we won't have an opportunity to talk about all these other exciting technologies and opportunities. So that was in my mind as I caught the recent report on the national labs. I'm now working with Berkeley Lab, but you could say this about any of the labs. I mean, Berkeley Lab, tens of Nobel laureates, hundreds of National Academies members, thousands of different sort of tools, equipment, sets of expertise that could be useful for these projects. We could be leveraging that in support of these awesome individuals who want to innovate, but it doesn't do anything unless the rest of the strategic community steps up, right? So the corporates, I think the Department of Energy wants to step up and support these things. I think they are. One of the questions we're thinking about, you mentioned public-private partnerships, is how do you get the corporates to step up? Because if there isn't, they're most likely, if it's not a startup, it's most likely that the corporates are the ones with the balance sheets and the distribution channels and the connections and the product lines to make this stuff happen. So, I'd be interested in talking to folks here about how do we make those connections.
Well, it's exciting times. There's no shortage of energy startups these days, and I love to read and watch the new things coming out of the national labs. I'll be excited to see some of the new things coming out, who's going to be the next Nest and all these things, and hopefully that comes out of the national labs. So thank you, gentlemen, very much. This was a great discussion.